So continuing with limits, I had you do this bell ringer. How do you do that? Okay, and how do you do that? Good. Multiplication is my only option, right? So the left-hand fraction, I'm going to multiply it by 2.
Could I have your attention, please? Dylan Pfeiffer and Babin Roses needs to come to the high school office.
Okay, any questions so far? Most common mistake here is don't forget to distribute the negative. So I get 6 minus x minus 2. I'm going to leave the bottom factored. 4 minus x or negative x plus 4, either way. Okay, so that is how you combine fractions. Why in the world do we need to know that?
The next question.
Okay, so what do I do first on this limit? On any limit, what do I do first? Put in 0. What do I get?
0.
I get 0 over 0, which means what? There is a hole. I have no idea where it is, but there must be one because I got 0 over 0.
Does it matter if you know if it's a hole or not? Because, I mean, if the bottom 0, you still do the same thing.
Now, if the bottom's 0 but the top isn't 0, then it doesn't exist. You stop. Because it's a vertical asymptote, so the limit at a vertical asymptote. You just stop. So that's easier if it's a number over 0.
And then when it's 0 over a number, it's just 0.
Right. If it's 0 over a number, 0 divided by anything is 0, so you stop. So the only time you keep going is if you get 0 over 0. I did. But the 2 techniques I learned yesterday don't work. What 2 techniques did I learn yesterday? I learned factoring and I learned expanding. Factoring where I try to factor the top and bottom and get something to cancel. Expand where I multiplied something out. You saw that on the homework with a cube. That was yucky. So those are my options so far. This doesn't fit either one of those options. But can I still try some sort of algebra? I could do what? Combine the fractions. Okay, that is the top fraction. Did I do that too fast? The left one needed a 5, the right one needed an x plus 5. Okay, simplify the top. What's nice that happens on the top? What cancels out? 5 minus 5, and so I'm just left with a negative x on top. Can you close that door for me, Caroline? Thank you. How do you divide 2 fractions? By the reciprocal? Everyone agree with that? Remember, I know there is a hole. I know there's something that will cancel. I'm kind of just looking for what that thing is that's going to cancel. And what is that thing?
That's going to be those x's.
Those x's, right? This x with that x? Those cancel to give me? 1. Anything division? It is -1, do we agree? Because that was a negative x divided by a positive x.
Plug in 0.
Boy, really?
Yeah.
Oh, wow.
Oh, wow.
Hi, sick people.
I actually think everyone's here today.
I know they're sick.
This is x over 1. So I multiply by the reciprocal. You know what I mean by that, so you flip it. Good question.
Hey, what are we doing Friday?
I would have to look at the calendar. I don't know.
Since I'm not going to be
Okay, remind me Thursday.
Beta.
Are you going, Bryce?
Mm-hmm.
Okay, try this one. Try this one. Hey, too much going on other than trying. Try that.
Yeah, I'll be on Tinder's team. Okay, what?
We're still doing limits. We'll be looking at limits for limits.
Is it?
So essentially, we're gonna, yeah. What we'll do though is we'll say that we're but is it 5? And of course, the limit is x equals 5 doesn't exist. But we'll ask what's the limit is x equals 5 from the left, and it's either positive or negative infinity, and we'll make that decision.
Oh, because if it goes like this, it's 5.
And we'll learn how to do that by.
Okay,
It's not a hard day,
that's good.
but that's essentially what we'll be.
And then you
Remind me Thursday and I'll give you a worksheet.
worksheet reset.
Remind me Thursday and I'll give you a worksheet. Any ideas?
Oh, I'm still working.
What do I do first?
Plug it in.
Plug in 3. Do you expect on the test that I will put at least 1 or 2 limits on there that all you have to do is plug it in?
Oh, I bet so.
Yes. Now, the bad thing about it is some of you will do all kinds of crazy things and miss it. Plug it in first.
I will not. I promise.
Plug it in first. I do get 0 over 0, which does mean there is a hole. I need to find it and cancel it.
Yes.
This, so I'm going to walk through my options. I can't factor, I can't expand, but I can combine fractions. So I just walk through the options. We've got 3 as of now. As we go, we'll add options. That's when you have something like this on top,
Oh, yeah.
and you foil it out. And so I get the limit as x approaches 3 of 3 minus x over 3x. Everyone okay with that part so far?
Yeah, sure.
That the common denominator?
Oh, that's the top.
Yeah.
You're talking about on the bottom.
Nope. The bottom, by the way, is x minus 3. So I get the limit as x approaches 3 of 3 minus x over 3x times what?
X.
1 over x minus 3.
Here, one.
Because this was over 1. Okay. I am still recording, even though no one is asked. Just mental note.
That way we can go home and laugh.
I'm gonna come back and watch our videos in 2 decades.
Okay. I know something must cancel, but at first glance I don't see it. Where do you see it? Good. Take a negative 1 out of one of these 2 pieces. Sounds good. And that makes this a negative and a positive. Those now cancel. Do you see why you did all that stuff in Miss Lowe's class that you did? The simplifying fractions and whatnot. Where did I get negative 1/9? Really quick. I plugged in the 3. As soon as I cancel the whole, plug it in. Hey, another method for today. Conjugates. First of all, let's talk about what that word means. What is a conjugate? We talked about it, Simon Trigg.
conjunction function.
Anyone know what a conjugate is?
It's the same thing, but differently.
Oh my god.
The square root of x plus 3 is the conjugate of the square root of x minus 3. You see those pop up often in the quadratic formula. Remember those two answers you get in the quadratic formula. But a conjugate is the same thing except with the opposite sign. Why are they important? Well, what happens when you multiply them?
They get the perfect square root.
You
The,
get one,
Square the where?
or you get.
the square root goes away. So you remember we did this when we were rationalizing denominators in trig? We multiplied by the conjugate to rationalize denominators because it gets rid of the radical. Square root of x times the square root of x is outer. I get positive 3 square root of x. Inner, negative 3 square root of x. Minus 9. Everyone agree? So in your future, it will be a big waste of time if you do the inner and outer on that multiplication because you know if they're conjugates, those are going to cancel. Okay, so that is how you rationalize denominators or rationalize something in general. So if you wanted to get rid of a radical in general, that's a way to do it. Why do I care?
Like this.
All right, so I've got some limits here. Now, we've always rationalized denominators, and there's a reason for that. The reason is before calculators, nobody wanted to divide by a square root. It was impossible. So they would rationalize denominators so that they weren't dividing by square roots. Well, obviously, that's a lost skill because we've got calculators. So why do we still teach you how to rationalize, even though you don't need to know for that purpose? Because you need to know for this purpose. So calculus teachers make Algebra 2 teachers still teach it because we would get mad at them if they didn't. Because we still need the skill for higher level math stuff. Even though you don't need it for computation anymore, we still need the skill. And here's why. What do you get when you plug in 4? 0 over 0, which means
Hole.
there's a hole. I'm going to walk through my options. Do you see anything that factors?
No.
No. Do you see anything that expands?
No.
Do you see any fractions?
Conjugates.
No, but do I see square roots? So this is method number 4. When you see square roots, I would like to get rid of them. I can do anything to a fraction I want as long as I do it to the top and the bottom. Now, we have always rationalized denominators before, but this time I think I would rather rationalize the numerator to get rid of the radical on top. So I'm going to multiply, whoops, not 2 square roots there. I'm going to multiply by the square root of x plus 2. Okay. What do you get on top when you multiply that? Hold on. Ooh, I'm sorry. What should be down there?
X radical X.
Because what is the only thing you can do if you multiply a fraction by something? That's right. I need to quit talking and writing at the same time. Okay, on the top, what do I get when I multiply those out?
X minus 4.
X minus 4. I hope that gets pretty quick to where you're not having to do a lot of work. On the bottom, I'm going to leave that factored out. I'm not going to multiply those together. And let's talk about why. What's my end game here? What's my goal? To get the whole to cancel. So factored form is better for canceling, right? So unfactoring it would be a bad idea. That would cause more work than necessary. So leave the denominator factored. Bye by 4s.
1/4.
Plug the 4 in.
Get 2. 1/4.
It's just some nasty algebra. How'd I get what? You sure? Okay. Let's look at the next one. What do I do first?
Here, hold.
What do I do first? Plug it in. Remember, I'm going to keep saying this every time, even though I'm showing you new skills. If you don't plug it in, I will trick you and you will miss one. Plug it in first. Because I could throw a radical in there and I could have that limit approaching 5. If that limit's approaching 5, the answer's a number, I quit. I'm done. Right? The only time it's a problem is if you get 0 over 0, which we do. So, what do I do? Right, I think of my options. Of course, if I could factor, I would factor. If I could expand, I would expand. If I could do fractions, I would do fractions. But I can't. But I do have square roots, so I can multiply by the conjugate of the denominator in this case. So I'm going to multiply the top and bottom by the square root of x plus 2 plus 3. And I'll try to write that correctly this time, on top and bottom. So I get the limit as x approaches 7. Miller, are you with me? The top, do I want to multiply that out?
No.
No, I want the x minus 7 to cancel, right? That's my game plan. Crossing my fingers, hoping it cancels. But I know that it does, right? How do I know that it cancels?
Because there's a hole.
Because there was a hole. I got 0 over 0, so there's got to be a factor on top when I plug in 7 that's equivalent to a factor on bottom.
Ooh, it does.
Okay, and what happens when you multiply square root of x plus 2 times the square root of x plus 2?
X plus 2 minus 9.
No, I explained it to you all.
And 2 minus 9 is? Good, so x minus 7, square root x plus 2, plus 3, x minus 7. And then what?
Then plug in a 7.
Plug in a 7. 7 plus 2 is 9. The square root of 9 is
3.
3. 3 plus 3 is 6. Any questions about using conjugates to find limits? Tricked me. I thought that was about to be a question. Ignore bell ringer. Sorry. Not a bell ringer. Let's try these. No. Good. Remember, these are the same notes I use for calculus AB, and they're always a little different on pace at this point because of the beginning of the year stuff. And y'all go a little faster through limits than they do. Because you're the best and brightest.
Yeah.
You all are all smart. Don't forget that class you're in may make you, not only are you in the smartest at Greenwood, but you're at a big school as well. Like if you went to Mansfield or something, I went there. Don't worry, I'm not talking bad about them, but you'd probably be the smartest, person in their math class. But you have to remember you got a bigger pool, so you got a harder comparison. So, and you are pulled into the smartest class, so of course it looks like you would. It will help your ACT score. I would take it soon because that ABC packet that we just did reviewed everything from Algebra 1 and then review some geometry.
Are we taking it in March?
Yeah, you are.
For free? Are you getting it today?
No, because you'll still be testing.
I know, but you
Yes, you do.
have to?
Every junior has to take it.
Oh,
I thought you said paper that you
Guys have
cut.
to take it?
Parent doesn't
Oh, okay. If your parent doesn't want you to, maybe.
I mean, most of the time.
Yeah.
Oh.
Free. Who's gonna turn down a free ACT?
Price.
Well, probably not. He'd probably have to sign the paper that says he doesn't want to.
Yeah, that's they also just take it try to make like
Why would you do that?
try and get zero. That's really hard, actually.
That would be tough. I don't think I'd do that.
which one it was.
I don't think I'd do that.
We had our first 0 in history.
Good point.
From our first few minutes,
0. He could do it because a 0 would be easier than a 36. Because because statistically you have a better chance of getting it wrong than right.
get a 0.
Well,
You must have yeah, not get.
Get a 11.
do a. But 36 would be harder than a 0 because you at least if you're aiming for a 0 you have the are there 5 questions on each one? So you have the 4 to 1 odds instead of the 1 to 4 odds.
I heard of one person got
It'd be
Try.
12.
Yeah.
I think 12's pretty easy.
I do something. That's a
It
pretty.
would be 2 plus.
Most are above a 12.
Yes.
Hey, I'm recording children. Okay, so the first one. What do you do first? Plug in 0. You get 0 over 0. Then what?
Then you conjugate
And what is the conjugate?
plus instead of minus.
On the top, I am going to multiply that out because I'm trying to get rid of that square root. And I get 2 minus 2 minus x. Be careful on that. Make sure you know the negative here goes with both the 2 and the x. Any questions about that so far? On the bottom, I'm going to leave that not multiplied together because I'm hoping that x cancels. Would you agree with that statement? That's my goal. 2 minus 2 is 0. Distribute the negative. I get a positive x on top. Which part? I could show. The x's cancel, which leaves a 1 on top. Better work down. I'm going to need that spot. So I get 1 over the square root of 2 plus the square root of 2, or 1 over 2 square root of 2. You could rationalize it. You could leave it. I don't care. That's the difference in calculus and trig. I don't care. Now, do you need to be able to rationalize? Yes, because half of the AP Calculus exam is multiple choice. So if you have to match a multiple choice answer, do it. If that involves rationalization, do it. But so you get radical 2 over 4. All right, let's look at the next one. And it's horrible. It's just mean. Why is it so mean?
Out at zero.
Both what?
Ungating and
We have fractions and radicals. Yeah, right. I would go through the order of
Operations.
the way I would work these. Fractions are slightly easier than conjugates, so I would go ahead and combine fractions first, get rid of the fractions to start with, and then if we must do conjugates, we will. We probably will have to. This one needs a square root of x. Does everyone agree with that? So I get the limit as x approaches 1 of 1 minus the square root. We did plug in, yes. Make sure you do.
Oh my gosh.
Flip and multiply.
Yay.
And I get 1 minus the square root of x over the square root of x times 1 over x minus 1.
Easy, man.
I'm gonna cry.
Do we have plus 4 in these?
On homework. On homework, yes.
What about this?
Not necessarily.
Miller was like,
Okay, any questions so far? Plug in 1. Try it, see if it works. Unfortunately, you still get... Do you agree that x minus 1 is kind of what I want to cancel? I kind of hope it cancels with something that involves the 1 minus the square root of x. So, I do in fact need a conjugate. But I do want to choose wisely. I don't want to do a conjugate of the square root of x because I have no problem with it. Does everyone know what I mean by that? So that's fine. So I'm going to multiply by the conjugate of 1 minus the square root of x, which is 1 plus the square root of x on top and bottom. Remember, to make your life not completely miserable, do not multiply that denominator out, because that would be a great way to make a horrible problem worse. Yeah, don't do that. 1 minus x, does everyone agree that's what I get on top? That's just a 1 multiplied there. Over the square root of x minus 1, 1 plus the square root of x. Good news. I at least now see what will cancel. I finally found the hole. I do still have to do one more set of factoring, don't I? -1 maybe out of the top. And then I get the limit as x approaches 1 of -1 over the square root of x, 1 plus the square root of x.
Where's that square root of x?
This one?
Yeah.
That denominator. Plug in the 1, and I get -1/2. That was horribly fun. Are they all that bad? Absolutely not. That's kind of your worst, probably your worst limit problem I could make up. That's probably it. Okay. It is. So if we don't finish these today, we will tomorrow. There are 2 special limits we're going to talk about and memorize. Okay, and on this first sheet, because we did not get to those 2 special limits, and there are a couple problems you won't get to work on, so
all
Where are the extra?
Here you go. That's around.
That